Good evening, my dear students. Welcome to the session. How are you? So, am I audible and visible? So, I have Prerna, Ananya, Tirthraj, Tushar, and Priyanshu. So, these are the people who are already in the session. So, we begin over with it. And today's session is extremely important. I believe I'll be able to hear myself. Perfect. My voice is perfect. I'm audible and I'm visible as I have seen it. So, my dear students, my five loyal serious student are on the channel. Welcome. And तुषार पाटीदार says आज मत पढ़ाओ क्यों ना पढ़ाऊं? Why you are trying to say नहीं पढ़ाऊं? And anyway, today thermodynamics chapter we are doing, and this is an important topic that we are going to do. If you have not done it, the last chapter, last session, that was 1 hour session in which I talked about the various terminologies of thermodynamics. If you have not attended, you can attend it now. Go ahead and attend that chapter, and then you can study this part. Now, this part is okay, a bit of independent part. You can understand this part even if you have not attended the last chapter, last session. But you have to attend this part because this is going to clear many of your doubts about thermodynamics. And please remember, this session is all about those students who have a trouble in chemistry, but they really want to score 180 on 180. So we are going to study for the students getting 180 on 180 because you very well know that at least 650 marks are required to get any decent medical college. If you want any government medical college anywhere, then 600 marks should be enough. But if you want to get decent medical college, 650 is required. Okay. So, Alapan Mishra, good evening, beta. Good Jitero. Prerna, Tushar Patidar, why not today? If you don't want to study today, go ahead and see the recordings. But I'm not going to cancel the class. Even if I have no student in the class, still the class is going to go on. Okay, Ananya, you have seen in the recorded form. So now we are going to start over with it. This is the introduction about me. I believe you very well know about me. So that's it. Now, we are going to talk about the physical processes. And before we get along with the physical processes, we are going to talk about certain terms, certain very, very important terms. And that term is what we call as the most important one here. That is called internal energy. Now, internal energy was the last topic that we did in last class. I told what is internal energy. I told what internal energy depends on. But internal energy will be used in this particular session to a very large extent. So we are going to talk about internal energy once again. Is this clear? चिंटू भाई यहां पर हम फील की बात नहीं कर रहे हैं, हम स्टडीज की बात कर रहे हैं. सर हमें बहुत फील आता है. When the people say I am not having feeling of chemistry, then in that case I feel like बेटा केमिस्ट्री में फील लाने के लिए क्या आपको सल्फ्यूरिक एसिड से नहलाऊं, सोडियम खिलाऊं या अल्कोहल पिलाऊं? क्या करूं फील लाने के लिए? आ जाएगा फील. Every day when you have the feel, that is chemistry only, because anything which you can feel, you can touch, taste, or smell, that is chemistry. Touch, taste, smell is chemistry. Okay. बढ़िया फील आएगा बेटा चिंटू. Okay, today we have 8 p.m. Another class, we have the strategy class on YouTube only at 8 p.m. And that 8 p.m. strategy class is all about how to score 180 on 180. So I'm going to tell you in detail what is exactly to be done on 180 on 180. So I believe you all are going to be there on that session. 8 p.m., 180 on 180, chemistry. Now, when we talk about internal energy is not just energy. It is the total energy content of the system. Now, this is the total energy content of the system, and this includes all kind of energies, all type of energies. Fine. And when we talk about all type of energy, the first part would be the mass. Mass. Now, mass is a constant if system is not open. Now, open system has a variable mass. If we talk about the closed system, we talk about adiabatic system, we talk about isolated system, all these cases, all three cases, the mass remains a constant. Clear? So mass remains a constant if system is not open. Then mass sometimes is confused with the number of moles. Now, moles constant if system is not open and process is physical. Clear? So the moles remain a constant if the system is not an open system and process is physical process. Clear? And that too, the moles can be considered constant if if the gases are not involved. Okay. Change is considered only in gaseous moles. Now, if the change is not in the gaseous moles, we do not consider it a change. But this is a change. If it's a physical process, then moles are not going to change in whatever be the case, चाहे gases हो, चाहे ना हो. But if it is a chemical process, then in that case, moles can change even if we do not consider it. Okay, so that's what we have as the open system, and that's what we have as first part of the internal energy. Second part, we have the internal energy. Now, this is what we have as academic or theoretical parts, because certain students have a tendency to ask, and most important, if you are talking about 180 on 180, this is the question you must be asking. What are the other parts of the internal energy? Then we can talk about the nuclear binding energy. Well, I have a tendency not to leave any kind of question that you might ask. Since I was a very khabti student, a very irritating student for my teachers, please remember all the irritating students, they tend to be the teachers. They become the teachers later. Because वो कहते हैं ना टीचर की बद्दुआएं लगती हैं, यू हैव डिस्ट्रॉयड दोस टीचर्स क्लासेस, तो टीचर की बद्दुआ ये होती है बेटा तू टीचर बनेगा तो पता चलेगा. मेरे साथ वही हुआ. So I was very inquisitive, I was very irritating student for the teachers. So that is why I can imagine those questions that you can't even imagine. I hope you are good students. I was not a good student. So U depends on temperature. Radhika, let me tell you what are the factors on which the U depends. I have just moved to the second factor. There are 7 factors. Let me go into the factors one by one. So it is nuclear binding energy. Nuclear binding energy is obviously the energy which holds together the nucleons, protons, neutrons together. That is what we have as the nuclear binding energy. Now, nuclear binding energy is going to change only in nuclear process. And what are the nuclear process? Nuclear process is what we talk about the nuclear fission, the fission bomb, okay, or nuclear fusion. That's a fusion bomb. That's what we call as even hydrogen bomb. And then we have the radioactivity. Okay. Please remember that for the nuclear processes, a huge amount of energy changes there. Even for the radioactivity we talk about, radioactivity, although it happens to be a kind of a spontaneous process, still it involves a huge amount of energy. Clear? So that is what we have as radioactivity. Jacques, let me give you the answer one by one. First of all, let me finish off the topic, and then I'm going to say if you want to ask any questions. I believe you won't have any questions. So that's what we have as nuclear binding energy. That is going to be only in the nuclear processes. Now, the third part of the internal energy is electronic energy. When we talk about the electronic energy, it is the ionization energy. That is the electron gain enthalpy. Okay. and it is something like spectra, or rather, I should say only the spectra. Ionization, electron gain, enthalpy, it's going to be more in the bond energy, and it's going to be included in that, the chemical process. So I'm going to simply talk about the spectra. Just remember, the excitation of electron is having more energy than any of the other chemical energies. The excitation requires even higher energy. The spectra actually requires more energy. So that is what we have, or you can say the electronic energy is photoelectric effect. So that is what we have as electronic energy when the electrons show transition. And the fourth energy that we talk about is what we call as the bond energy. The bond energy is the change whenever a chemical process takes place. A chemical process is the one where there is more or less change in the bond energy. If there is no change in the bond energy, it is not a chemical process. Clear? Fine. So that is what we have as the bond energy. Now the fifth, sixth, or rather I should say the part. Now the fifth is the kinetic energy. Clear? That is the energy due to motion of particles. When the particles move, there is no chemical change in it. The particle nature does not change. If the velocities of the particle change, the average kinetic energy changes. There is no change in their chemical behavior. Clear? So kinetic energy is motion of the particles. And when we talk about the motion of the particle, this is also termed as thermal motion. Clear? Now, kinetic energy is of three kinds. One, we have the vibrational, then we have rotational, and then we have the translational. Now, these are the thermal motions that we talk about. Please remember, these energies depend on temperature. Clear? So, change only with change in temperature. A process in which there is no change in the mass, the nuclear binding energy, the electronic energy, and the bond energy is called the physical process. In a physical process, only the change in thermal energy is allowed. It is not necessary that in every physical process the change in thermal energy will occur. It's not necessary. But if there is a thermal energy change only, then it's a physical process. Is this clear? So, if energy change is only thermal, it is a physical process. Is this clear? So that simply means in a physical process, the energy change will take place only if there is a change in temperature. So ये बात याद रख लो, लिख लो, ठीक है? So that's what I am writing. In a physical process, energy change is possible only with change in temperature. But remember, it's physical process. Remember, okay? Now, one thing I would like to make very, very clear. Change of state, change of phase That is, you convert solid to a liquid, liquid to a gas. You dissolve some substance in a solvent. You make a solution. This is a change of phase. Clear? Thermodynamically, it's a chemical process. Thermodynamically is a chemical. Clear? Because here there is a change in bond energy. Remember it. Just put it in your mind. So now you would ask, what is going to be the physical process? Physical process is expansion of a gas. Change in temperature such that there is no change in state. Let's say water is taken from 10 degrees Celsius to 30 degrees Celsius. Now that is a physical process. Steam, 110 to 130 degrees Celsius. That is a physical process. The gas expanding against constant pressure, or gas expanding against a variable pressure, or the temperature of the gas is being changed, or the gas is being heated or the cooled. No change in state, no change in chemical behavior, no change in moles, then it is a physical process. Am I clear without any confusion? Difference between state and phase. Phase is anything which can be distinguished visually. That is a phase. Now, when the state changes, phase always changes, but there is a same phase with different, different states, or rather, I should say, different phases with same state. That is also possible. Okay, there is no difference between state and phase. Change in phase or change in state is also change in phase, but change in phase does not always mean change in state. Is it clear? If I change rhombic sulfur to monoclinic sulfur, then in that case, the phase would change, but the state would remain the same, solid. If I have water and oil, the water and oil both have the liquid phase, but they are liquid state, but the phase are different. Is this clear? Okay, so that is what we have as the difference in the state and the phase, and thermodynamically, this is a chemical process. So that is what we have talked about the internal energy. Now there's somebody about asking whether we can measure the internal energy. The answer to that is very straightforward. Many components are relative. Like when we talk about the potential energy of a substance, potential energy is relative. What is the position of the substance? Since many of the components of the internal energy are relative, so absolute value cannot be determined. Is this clear? So absolute value of internal energy cannot be determined, but we can actually find the change in internal energy, because the one particular state can be considered as zero, and another state we can find what the total energy is, or what the change in energy is, how much energy we have provided to the system, how much energy the system has lost. So we can actually measure the change in energy rather than measuring the exact value of energy. Any confusions? So I hope my dancing is not required to make it clear to you. Sir, move करके पढ़ाइए. Move कर लिया बेटा. I'm moving. Fine. Feel आया? Now, so this is absolute value cannot be determined. So this is what we have as internal energy. Okay. Once we have talked about the internal energy, there is a term called heat and work. Now, most important term becomes work. Now, when we talk about the work, we are going to talk about physics. Clear? There are so many kind of work. The most important work that we talk about is what we call as the force displacement work. If you have done a bit of physics, a little bit of physics, of course, the physics is in your course, and that work you would have done even in lower classes. So if we talk about force displacement work, it is FDS, force into displacement. Or you can talk about F dot D of F dot S. Force is a vector quantity. S is a vector quantity, that is displacement. Now, this is a scalar quantity. Work is a scalar quantity. So work never has a negative sign. We don't call it negative work or positive work. We simply call it work. Clear? So that is what we call as work, F dot ds. Now, you can very easily understand. Okay, displacement is what we call as the intrinsic quantity, or rather, I should say state function. But force is something which we can change. For the same displacement, we can have different force. So, how much work is being done, it will depend on how much force you apply. For the same displacement, we can have different work depending on how much force we applied on it. So whenever you have to ask a question, how much or how it has been done, it becomes the path function. It becomes the path function because you need to specify how much force has been applied. Now what we can do is we have force. We divide it by area. Like let's say we have this kind of a place. This is a container. And here we have a movable, frictionless, massless piston, which does not exist. Now, this piston can be moved up, this piston can be moved down, or depending on what the pressure we apply. Now we have something like P external. Okay. And then we have P internal. The pressure external and pressure internal. They are acting opposite to each other. They act opposite. Clear? Welcome, Mayuri. How are you? So, Mayuri, I believe you have already liked the session. So, whoever is here, please like the session. And I believe you have already shared the session with all your friends. So we are doing thermodynamics at this moment, and we are going to do in detail nicely in this very long session. This session is going to go up to maybe till 7 o'clock, till the time we don't finish off the physical part. Okay, then we are going to start with chemical thermodynamics in the next session. Okay, so here pressure is equal to force divided by area. So this is the area on which this force is being exerted, so it becomes pressure. And here, when this changes, there is going to be a change in volume. So will be a change in volume. So it is F by A dot displacement into area, A ds. So now this is going to become dV and this is going to become P. So W is going to become P dV. Is it clear? So P dV. No problems? Now, there is a peculiar case, a peculiar thing. Pressure of gas is positive. Pressure of gas is positive. Clear? So, the external pressure acts opposite to the pressure of the gas. So, by default, the external pressure is negative. So, external pressure is negative. Okay. So, external pressure would be written as minus P external. The pressure of the gas is P gas. Any confusion? Clear? So it so happens, remember this, any confusion still now? It so happens because of this particular convention, because of this particular convention, work done by gas is positive. And please remember, we are always doing the work against the external pressure. Yeah. So work done by the gas is positive, or we can say it is plus PdV. Work done by the gas is positive, that is plus PdV. Or this can be said as work done by the system, because gas is the system. Now, this is the work done taken in physics. So whenever we talk about physics, the work done is PdV plus PdV. Clear? Now, work done on the gas. Obviously, that is done by external pressure. It is in the direction of the external pressure. Is negative. And that becomes minus PdV. Clear? Now, this is the work done on the system. Now, when we talk about this work, now this is what we call as expansion. This is work expansion. Now, when we talk about this work, this is in chemistry. And this work done is compression. So in chemistry, work done is minus PdV. Am I clear with that? Yeah, Zekas, Zekas, whatever your name is. This is IUPAC. Obviously, IUPAC is for chemistry. So they are going to use the convention of chemistry. So they have the logics that we are observing the system. So we should be considering what the change is taking place in the system. But the physics talks about what change takes place in the surrounding, because if the work is being done by the system, the change is in the surrounding. So that is what we say. So this is what we have as the system and the surrounding. This is what we have as the work done on the gas. This is going to be negative. Am I clear? So now if the work done, this is what we have as minus PdV. That is the work done in chemistry. Work. Now, having talked about this, let us talk about something more. Let us talk about one more term. Clear? Now, that one more term that we talk about is called enthalpy. H. Now, what is enthalpy? Enthalpy is the heat content. Okay. Now, when we talk about the internal energy, the U. Now, U is internal energy. U is internal energy. Internal energy is equal to the sum of the two components. One component is enthalpy and another component is work. So this is enthalpy and this is work. The total work content in the system. Fine. Now, W is equal to minus PV. W is minus PV. So the formula for internal energy becomes equal to H minus PV. Because beta, physics and chemistry, they always work opposite of each other. The reason for that is that chemistry was denied a status of science by the physicist. They didn't consider chemistry to be science and they always made fun of chemistry, calling it alchemy. Alchemy means the madness. Clear? So, because the people who are using alchemy, they were talking about two things. They were talking about elixir of life. Now, this is the channel we have as NEET Elixir. They were talking about elixir of life, the thing which is going to make you immortal. And second thing, they were talking about gold. They were talking about converting something into gold. So that was alchemy, and that was considered to be madness. So they always made fun of chemistry. But later on, Antony Lavoisier, who was an influential person, he actually did chemistry nicely. And so chemistry became the group of elite people who had a lot of money and they wanted to be out of the shadow of physicists. Those people were not very intelligent, but they wanted distinction from physics. To get the distinction from physics, whenever there was a overlap of chemistry and physics, the chemistry people deliberately took the opposite convention. Deliberately. And they had the logic for that. Because chemistry was a new science at that time, so they had more knowledge and they had the capacity to change the convention. So they did it. Jyotiraditya Vara says, what is the reason of yours that why are you not as famous as other NEET teachers? Well, I don't know. Maybe I'm too strict. Maybe I make the student work very hard, and nobody likes to work very hard, isn't it? Okay, fine. Well, you can judge it for yourself that why I should not be so famous. I would say I'm very less famous because my class has at this moment only 9 students. Isn't it? So I am the least famous. But I have been given an opportunity to teach these few students and to my maximum capacity. That's what I'm going to do. Clear? So at this moment, I'm teaching the students to their capacity. How much you can learn, I'll be able to teach you. I'll have to see whether I'll be able to teach the student to my capacity or not. Arman Ali, what details am I not teaching? Could you please point out what did I miss? Okay. Jacques, forget about no one wants to learn in English. That is not the concept. Even if I start teaching in English, still I'm not going to get more student. Okay. That is not the reason. You want to learn in English or you don't want to? My English is not that difficult that you won't be able to understand. Okay. Now let's get along with the concept. Not wasting time. So this is the change. This is the internal energy. Now let's talk about the change. Change. Change is always final minus initial. The change, whenever we talk about change, is always final minus initial. Most often, final is represented as U2 and initial is represented as U1. Or you may even consider U final, U initial. Up to you, conventions are for you to understand. Whatever convention you use, just mention that I am using this convention and that should be good enough. Okay. So this is U final and initial, U2, U1. And when we talk about the change, that would become U2 minus U1 or U final minus U initial. So that is going to be the change. Fine. So that's what we have discussed about what is going to be the change in the internal energy. But then if I have U final, that would be equal to H final minus P final V final, or you may consider it as this would also imply U2 is equal to H2 minus P2 V2. Okay. Most often we are talking about one state and other state. We can always go from up to down, down to up. Anyway, so it is generally 1 and 2 which are used rather than final and initial. Okay. Arman, you did not mention what details I missed. Would you be able to tell me what details I missed? Okay. Now, when we talk about this U2, this fine, then you can have U initial, which you can mention as H initial minus P initial V initial. That can also be written as U1 is equal to H1 minus P1 V1. Okay. Have you noted it down? Please note it down thoroughly, nicely. Okay. Once we have noted it down, now let's say change. Change is U2 minus U1. That will be equal to H2 minus P2 V2 minus H1 minus P1 V1. Is it clear? I hope I'm not jumping. I am doing it one by one. Ananya, the disturbance, the when I reply them, that doesn't make a lot of difference. Fine. So now, okay, whenever we are talking about a substantial change or a change from one state to another, a measurable change, we put delta U. That will be equal to, now, let's say we separate the variables, we put the two similar variables together. So it is going to become H2 minus H1 minus P2 V2 minus P1 V1. Okay, we have used the cumulative property of addition and subtraction, that we can add or subtract anything together. We can just put them together. So that's delta U becomes equal to delta H minus delta PV. Any kind of doubts? Any confusions here? Now we know PV is equal to nRT. That's what we have done in the gaseous state. And the NCRT this time has eliminated the chapter called gaseous state, but PV is equal to nRT is required. Now, if we talk about delta PV, and please don't forget to put the bracket. If you don't put the bracket, then in that case, delta will be associated with one of the terms rather than both. I want any of the change could be occurring. That is equal to delta of nRT. Now, R is the gas constant. It is not going to change in any condition. So, delta PV can be considered equal to R delta NT. Is this clear? Jacques, that is differential. I'm not talking about differential at this moment. I'm simply talking about the change. Okay. And Jacques, I am not very proficient in mathematics. And I don't have any regrets with that. Clear? Fine. So, what we can get is delta U can be written as delta H minus R delta NT. Any kind of confusions here? Anybody? Anyone has any kind of confusions here? Okay. Prerna, again, you are answering the questions of the other students. Forget that. So this term, this statement, learn it. Learn. Okay. And what we can do, we can just turn it around. Turn it around, we can have delta H is equal to delta U plus delta PV. Or I can say delta H is equal to delta U plus R delta N. Any kind of confusions? Now, today's topic is physical process. So let's talk about a bit of physical process. In physical process in a closed system. Closed system means mass constant. Moles remain constant. Okay? So in a physical process where the mass is constant, the moles remain constant. Please remember it is for the physical process. This is a silly mistake that you can commit in the examination. And depending on that, the AIMS has asked reason assertion question. The standard has been decreased a lot, but they are slowly increasing the standard now. The NCRT are being revised, the NCRTs are having more information, and that's what we are going to see when we are going to see the chapter through NCRT. The thermodynamics chapter in NCRT is very haphazard. It is extremely difficult to understand unless you have attended the class. So just be very careful in the class, whatever I'm telling you. Okay. So in physical process in a closed system, mass remains a constant. So delta H is equal to delta U plus delta PV. It becomes delta U plus R delta NT. Now N is constant in a physical process. So this becomes delta U plus NR delta T. Now this is going to be valid only for a physical process. Clear? Whoever has not liked the class as yet, go ahead and like it. So that's what we have as the physical process, and that's what we have as enthalpy and internal energy. Am I clear with what is enthalpy and what is internal energy? So I believe we have distinguished the processes on the basis of physical process. What is a physical process? We are going to talk about chemical process a bit later, but I have already given you a hint about what is a chemical process. Clear? Now we are going to talk about the classification of the processes. Till here, anybody has to ask anything? Last step. Last step, n is a constant. N constant. So constant does not change. This delta is not going to change the constant. The final and initial value of n will remain the same. N final is equal to n initial. And that is why this can be taken out from the delta. Tirthraj, is it clear? Arman Ali, you were talking about that I am not going through the details. N is constant because it is a physical process. Here it is written. Here it is written. Arman, are you asking the question for the sake of asking it? Or you really have a problem? Is it clear? So N is a constant because it's a physical process. Now, so that's what we have talked about. Once we have talked about this, now let's talk about something called reversible and irreversible process. Clear? Now, can anybody give me the first law of motion? The physics? Physics, the first law, Newton's first law of motion. And that first law is the law of inertia. An object stays at rest or in a state of uniform motion till an unbalanced force acts on it. That is the Newton's first law of motion, isn't it? Any kind of confusions? Clear? Arman Ali, is that clear? Okay, tell me one thing. Here I have a mass of 1 kg. Okay, I move it through a distance, or I should say displacement or height of 1 meter. I should not write 1 meter here. I should write 1 meter here. So mass of 1 kg is moved from a displaced distance through a distance of 1 meter against a force, an acceleration due to gravity of 10 meter per second square. Okay. What is the work done by? What is the work done by me? Any difficulty here? Give me the answer. Or how much energy has been spent by me? I can even say what is the work done by me is the energy spent by. Tell me. So Tirthraj Mukherjee has given me the entire first law of Newton's first law of motion. A body continues to be in its state of rest or state of uniform motion along a straight line unless it's acted upon by some external force to change the state. Clear? An external force to change the state would be meaning unbalanced force. Am I clear with that? So you say the work done, W is equal to 10 joule. Now work done by me is 10 joule. Now if this object moves down, it will be doing the work of 10 joule. Is it clear? Okay. The force exerted by me is 10 newtons. Force exerted by me is 10 newtons so as to move this object above. Everything is clear. Now tell me, Tirthraj, if this is the mass and I apply a force of 10 newtons on it, will it move? Tell me. If I apply the force of 10 newtons on it, will it move? No. 10 Newton would be the force which is required to balance it, not to move it. If I exactly apply a force of 10 Newton, it is going to be balanced, it's not going to move. Am I clear with that? Does anybody have any kind of confusion with that? Does anybody have any kind of retaliation to that? So that means work done by me, W me, is greater than 10 joule. Any direction, Jacques. If I apply 10 joule of energy, if I apply 10 Newton of the force, then in that case, the gravitational force is going to exactly balance it and it's not going to move at all. I'll have to apply slight higher energy, slight higher force. The higher the force I apply as compared to 10 Newtons, faster this object will move. Faster the object will move. Prerna, let me give you something more. I want to wash my hands. I use a little amount of soap. Is the entire amount of soap I use is consumed? The water moving out of my hand does not have any cleansing property. Is there no soap which has remained unreacted? Don't you believe that I have wasted some soap? The water I use to wash my hands, is entire water dirty? Will it not be, will this water cannot clean? Am I not wasting water? An important thing is, faster I want to do it, more wastage I'm gonna do. Prerna, is that clear? Faster I want to do a process, more I waste. Clear? Anyone has any kind of doubts? So that means work done by me is equal to minus mgh plus delta W. Jacques, is it clear or not? Jacques, is it clear or not? That there will be a delta W which is wasted, which I cannot get back from the system. Will there always be a delta W which is wasted, which we cannot get back from the system? Goes in the environment, irreversible, irreplaceable. If I get the system same place to the position of the initial position, the surroundings don't come to the initial position. Surrounding have some extra energy. Agreed? Jacques, is it agreed? Okay, agreed. Now let us define a reversible process. Let us define a reversible process. A process which, when reversed. Remember, the thing is which, when reversed. It's not necessary that I have to reverse it. It's not necessary I have to reverse. Okay? Which, when reversed. I need to know that which, when reversed, system and surrounding. That is, you can simply say universe reverts to its initial state. System and surrounding both revert to the initial state. That is a reversible process. Now tell me, was this simple process of taking a 1 kg mass through 1 meter and back a reversible process? The system has come back to its original position, but are the surroundings on their original position? This delta W is the irreversibility. More is the force I apply as compared to the gravitational force, more irreversible the process becomes and faster it becomes. Got it? Clear? Faster the process, more irreversible it becomes. Take any process. Take any process. Faster you want to do it, more wastage you incur. And that wastage makes the process irreversible. Take any example in this universe. Any example. Every process that actually happens is irreversible. And somebody would say, sir, equilibrium. But equilibrium is not a process. Equilibrium is a state. And when the system reaches equilibrium, Nothing happens. Zequas, where are you? Are you there? Ananya, Prerna, Tirthraj, Radhika, Priyanshu, Arman, any doubts? Now let's try to make our process reversible. Let's try. We won't be able to, I know, but let's try. So if say how to make our process reversible. A process may become reversible if the force favoring the process is infinitesimally greater than force opposing it. Fine. The system is always at equilibrium and takes and process takes infinite time. Straightforward, the process does not take place. Zikos, I have just told you. It can be reversed by infinitesimal change. Infinitesimal change would mean infinite time. So when the process will take place? Is it actually taking place? You have just given the answer to your own question. Clear? Clear? And what is infinitesimal? What is infinitesimally small? Let me give you an idea. Infinitesimally small. What is the meaning of that? Infinitesimally small. Okay. Now let's say there is number 1 and there is 0.9 bar. Can you tell me which one is greater? 1 or 0.9 bar? Which one is greater? Okay, Zequas, am I clear to you? I'm not debating at this moment. Have I cleared it? What is infinitesimal change and what is reversible and irreversible? Are you convinced or you want to ask a question? So Arman says 1 is greater than 0.9 bar. Okay, fine. 1 is greater than 0.9 bar. But can you tell me the value if I make it 1 minus 0.9 bar? What is the answer? By how much? By how much? Well, everybody agrees that 1 is greater than 0.9 bar. But by how much? What is the difference between the two? Yes, it is zero point 0.0 bar infinite and then 1. Now this is infinitesimally This is infinitesimally small. And for all values, 1 is equal to 0.9 bar. You take them equal. Fine. Take one from here, take one from there. I hope you know how to convert the recurring decimals into fraction. If you know it, you will get 0.9 bar equal to 1. Clear? So that's what we have as infinitesimally small, and that's what we have as reversible and irreversible process. Fine? Now, in our studies now, in today's studies, we are going to consider all process to be considered now are reversible physical process taking place in a closed system with ideal gas as working substance. Clear? So if it is reversible process taking place in a closed system with ideal gas as a working substance, that means mass is constant, number of moles constant, okay, internal energy changes only with temperature. Is this clear? But I can't block him because I don't have the admin rights, or you should say, or studio rights. Go ahead and block him from your chat. Okay. Dr. Allah Ditta says that detail से study करवाइए मजा नहीं आ रहा. Okay. What exact details I am missing? Could you please tell me? Yeah, we have total 10 students, and there also we have trolls. If you want to troll, कम से कम उस जगह पे जाओ ना जहां पे बहुत सारे स्टूडेंट है. यहां पे ट्रोल करके क्या मजा आएगा? So this is what we have as internal energy changes only with temperature. That's what we have talked about. Fine. And Dr. Allah Ditta, thanks for giving me a precious view. Fine. So let's talk about the various processes, the various physical processes. To begin over that, first of all, we talk about something called the cyclic process. Cyclic process. A process in which, and mind that cyclic process may be reversible, may be irreversible. Cyclic does not mean reversible. Which the system reverts to original state after various changes periodically. Okay, like a pendulum, a cyclic or periodic function, or it may be talked about, let's say we talk about internal combustion engine. The piston moves down and up. It reverts back to its original state after a certain cycle. Okay. When we talk about a cyclic process, change in all state properties is zero. Okay. But path functions may change. The most often change is that you provide heat to the system and you are getting work from the system, or you provide work to the system and heat is ejected out. So heat and work, they keep on changing, but the rest of the state functions, they don't change. You join the class late and you don't even know whether I'm going doing doing it in detail or not. कमेंट मार दो, बाद में देखा जाएगा, है ना? कुछ भी मार दो यार, टीचर है, यूट्यूब पे पढ़ा रहा है, बोल दो जो बोलना है, क्या फर्क पड़ता है? कुछ कर थोड़ी ना सकता है ना? Okay, so that's what we have as the path functions that may change. The state properties, the change is zero and path functions can change. So that is what we have as the cyclic process. Now to begin over with the actual thorough process. And then we talk about isochoric process. Isochoric process. Isochoric means constant volume. Constant volume. So that would mean dV is equal to 0. V is equal to constant. Clear? Now, when we talk about work, dW, in chemistry, the work is minus P dV. In chemistry, it is minus P dV. So, since dV is 0, dW is 0. So, work done in case of isochoric process is 0. Whether we talk about physics, whether we talk about chemistry, 0 is 0. It is not negative or positive. Fine. Now we use the simple equation. Delta H, or rather I should say, okay. Oh, I missed a very important thing. Let's talk about the laws of thermodynamics. Clear? Thermodynamics has four laws. There are four laws of thermodynamics. We have the first, second, third, and we have zeroth law. We have the first, second, third, and we have the zeroth law. Now, zeroth law was formulated after first and second law, but it is even more important than them. The first and second law are based on zeroth law. So that is why it was termed as zero. They cannot change the name of the laws once they have formulated it. So they made it zeroth law. Okay. So first of all, we talk about zeroth law. Zeroth law is saying simple. It's talk about thermal equilibrium. We talk about the three objects. This is B, this is C, this is A. Okay. A is in thermal equilibrium with B. See, when we talk about thermodynamics here, we are talking about early thermodynamics when energy was just heat. So we are talking about early thermodynamics when the energy is simply heat. Okay, we are not talking about any other form of energy. We are simply talking about heat. Okay. Now, A is also in thermal equilibrium with C. A is also in thermal equilibrium with C. The zeroth law of thermodynamics says that B and C also are in thermal equilibrium with each other. So if you make a change in any of these three, the other two also are going to change. So there will be a flow of heat. Is that clear? That's what I said, Jacques. Okay. So that is what we have as the zeroth law of thermodynamics. And then we have the first law. We have the first law. Now, the first law is law of conservation of energy, which says that energy can neither be created nor destroyed. It can only be transformed from one form to another. So that is the first law of thermodynamics. Now, first law of thermodynamics, let's say we have a container, and in this container we have some water. We put a thermometer in it, and we put a stirrer in it. We put a thermometer in it, and we put a stirrer in it, and we heat it. Now, when we put a thermometer and stirrer in it and we heat it, what we find it and we stir it. Now, stirrer does work, and this provides heat. So the change in internal energy of the system is equal to the sum of heat provided to the system and work done on the system. Now, this is mathematical representation of for first law. Anyone has any kind of doubts here? Very clear? Hmm. There are so many statements of the first law of thermodynamics. Now, We are going to use that law here for isochloric process. So we know delta U is equal to Q plus W. Right? Now, since we know dW is equal to 0, so W is equal to 0. So delta U for constant volume. See, we talk about the subscript. The subscript means the volume remains a constant. Arman, first of all, let's finish off with the physical chemistry, and organic chemistry is going to start in plus class first. Okay, so that is equal to Q. That is Q. What is Q? Heat provided to the system. Q is the heat provided to the system. Quite obviously, we are going to do NCRT. We always do it. You don't need to tell me. NCRT is already there. See, you want to see the NCRT? Okay, here is NCRT. Here is NCRT. Okay, you want to see the NCRT? Go ahead and see. Okay, open the NCRT. We have already seen certain topics, certain things. Open the NCRT, quick. Read it. Request NCRT. I'm not exactly teaching this chapter from NCRT because this chapter actually deviates. It is quite haphazard in NCRT. Just read through to NCRT. Anything you want to ask in this particular part? Open your NCRTs. There are 9 students. I hope you are having the NCRT with you at this moment. Well, this class is going to go according to you. Anything you want to ask in this part? Okay, read through it. Now these are the thermodynamics terms which we did in the last class yesterday, that first session of thermodynamics. Just read through it, and if anybody has to ask anything, go ahead and tell me. I hope that you will be able to understand this once I have taught you. Anybody has any kind of doubts? Yes, boundary is a part of surrounding, Ananya. I told you. Okay. But boundary is considered to be very thin or negligible in thickness. So that is why we can consider it to be a separate entity altogether. And boundary may be imaginary as well. If boundary is imaginary, then in that case, there is no meaning of considering it to be a surrounding or system. But if it is physical entity, it is the part of surrounding, not the system. Is it clear? So here we have type of systems, open, close, isolated system. Read through it. What happened to this? So here are state variables and state functions. Here we have talked about something like work. We have talked about what is adiabatic wall, thermally insulated. Then this is the internal energy as a state function. Just go ahead and read it. I hope you will be able to understand it till this point. But it is here it becomes random. Here they are mixing it up. It's putting adiabatic work in it, isothermal, isochoric, everything at the same time, as if you already understand it. Which graphs are we talking about? We are not reached to any graphs. I have not seen any graph as yet. There aren't any graphs. Where are the graphs? आने दो ग्राफ को. Okay. Now this is the first law of thermodynamics. This is what you need to understand. Okay. Here, read it very nicely. Very important. Read it. This subsystem. Okay. So here we talk about work, and this is the graph which I did with the piston. This is the same thing. This isn't a graph. This is actually the working of the piston. Is this clear? Okay, now I think you will allow me to get back to my way of teaching. Okay. And I would request you not to read NCRT any further till the time we don't finish it. We still have 1.5 hours. We have only done the class of 90 minutes. Anybody wants to have water? Go ahead, take a sip of water. I'm giving you 3 minutes break. 3 minute break. Go ahead, take your water. This class is a very small class. So even if one student wants something, I have to do it. 3 minutes. That is, we are going to start the class at 5:32. Okay, let's begin now. You are back. So we are also back. We are going to begin over the session. Okay. So that was isochoric process. In the case of isochoric process, what we find is that is what you need to learn in an isochoric physical, or rather, I should not say physical, in an isochoric process, the heat supplied to the system is equal to the change in internal energy. So it behaves as a state property. Internal energy is a state property. So heat change also becomes a state property when it is isochoric process. Armanal says this chapter is not important NEET. Armanali, could you please tell me which is the most important chapter? Which is the important chapter? Very few questions come in NEET. Armanali, can we consider that one question comes in NEET? One. Just one. Is there any NEET paper in which thermodynamics, none of the question has been there? I'm just talking about one. Is it worth it or not? Now tell me. One question only. If you leave all the chapters in which from which only one question come, then in that case, I believe you are going to leave at least 20 chapters. Very few. That still means at least one. You cannot have zero point 0.1 question, isn't it? Okay, fine. And most important thing is, if you don't do thermodynamics, you will not be able to do many of the questions in inorganic chemistry. Inorganic, you won't be able to do. Okay, so this is what we have as an isochoric process. The heat supplied to the system is equal to the change in the internal energy. Is that clear? Fine. Now, we have an equation, and that was delta H is equal to delta U plus delta PV. Clear? For isochoric, V is constant. For isochoric, V is constant. So delta H becomes equal to delta U plus V delta P. Please remember, for an isochoric process, the enthalpy change doesn't become zero. Okay, it is delta H is equal to delta U plus V delta P. There is a change in pressure, and this is what we have. Am I clear? Okay. So that was what we know as the isochoric process. Now let's get along with something called isobaric process. Isobaric process simply would mean pressure constant. So isobaric process is the pressure constant. Now, when we talk about the pressure constant, we have again W, dW. dW is equal to PdV minus PdV. Now, volume is not a constant, pressure is a constant. So, dW is not equal to 0. For a physical process, dW is not equal to 0. Clear? dV is not equal to 0. Now, to find out W, we have to integrate it. Now, this is integration, a simple integration. We have it from 0 to W, dW. Now, that's equal to from V1 to V2 minus P dV. Yeah. Now, minus P is a constant. It will be taken out of the integration. I'm not going to go into much of the integration. I'm simply telling you the answer. So here it becomes W is equal to minus P integral V1 to V2 dV. Now that becomes equal to minus P V2 minus V1 and W becomes equal to minus P delta V. Is that clear? Fine. So if I talk about delta U is equal to Q plus W, delta U is equal to Q minus P delta V. Okay. And then PV is equal to nRT. P delta V will be equal to nR delta T. For a physical process, it is nR delta T. So delta U is equal to Q minus nR delta T. And that's for physical process. Fine. Now, one thing more. We can say here, next page I can go. Q can be written as delta U plus P delta V. Q is equal to delta U plus P delta V. Any kind of confusions here? So let's say this is the equation number 1. Then we have delta H is equal to delta U plus P del oh sorry delta PV. And this delta H will be equal to delta U plus P delta V at constant pressure. This is the equation 2. Can you see something in relation with constant, the two equations? Okay. Arhan Dar, pressure is constant. So there is no P2, V, P1. There is only P. Okay. So we have, right, like here we have delta PV. Delta PV is P2, V2 minus P1, V1. But P is constant. So this actually becomes PV2 minus PV1. So P comes out to be constant and P becomes PV2 minus PV1. And that is P delta V. Clear? Arhan, what you have written is a general statement, but when the pressure is constant, it becomes P delta V. I hope I have been able to clear your doubt. So that simply means from the equation 2 and 1, delta H is equal to Q at a constant pressure. So heat provided, heat provided to a system at constant pressure is equal to the change in enthalpy of the system. Any confusions here? Copied it down? Rajkumar, I have taught in many places, not just there. Okay? So that was the isobaric process. Now let's get along with another process. That's what we call as isothermal process. Isothermal process. What have you not understood? What was the last line? Heat provided to the system at a constant pressure is equal to the change in enthalpy of the system. This is the last line. What have you not understood here? Arman, how is it coming? What is coming? What is coming? Arman, we have already done this before. What is coming? How is the last equation coming? This one. The equation 1 and equation 2. Check it out. Q is equal to delta U plus P delta V. Delta H is equal to delta U plus P delta V. So delta U plus P delta V is the same in both the equations. So Q becomes equal to delta H. Okay, Arman Ali. And please remember it is not H equal to Q. It is delta H equal to delta Q. It is delta H equal to Q. Delta U doesn't become 0. Who said delta U becomes 0? I never made delta U 0. Anything, everything. कुछ भी. कुछ भी चलता है. Arman, in this class, you are not allowed to lose your focus. You are not allowed to lose your focus. If you want to go to toilet, then you have to tell me, sir, may I go to toilet, please? You have to tell me. You cannot go to toilet without telling me. You cannot move your eyes from the class without telling me. That is the reason why I don't have many students in the class. Got it? Okay, Arhandar, let's talk about the isothermal process. Isothermal process, we have constant temperature. We have the constant temperature. That is what we call as isothermal process. So del dt is equal to 0. Fine. Now, please remember, we have the physical process. If we have the physical process, that is an isothermal physical process taking place in a closed container having an ideal gas as a working substance, for an isothermal physical process taking place in a closed system having an ideal gas as working substance. Delta U is 0. Arhandar, what exactly are you saying? Delta T is directly proportional to temperature. Delta T is change in temperature. How can it be proportional to temperature? Clear? Arhan, it is not proportionality. Okay? Okay, fine. So here we have delta U is equal to 0. Well, personality or proportionality also works. So we have delta U at a constant temperature is equal to Q plus W. Delta U at a constant temperature is 0 for a physical process. So 0 is equal to Q at a constant temperature plus W at a constant temperature. So we get two equations. We get minus Qt is equal to W. Okay. Or you can say minus Wt is equal to Q. Theoretically, both the equations are same, but their meaning is different. Meaning is different. Here it means that whatever heat is released by the system is equal to the work done on the system. Whereas here it says whatever is the work done by the system is equal to heat provided to the system. Now this equation is not practically possible. You cannot convert the entire heat provided to the system into work. Arhandar, why are you so angry? Yes, I always remain angry. Okay. That is why the students are not in my class because I always remain angry. मैं डांट मार देता हूँ बेटा बहुत बुरी तरीके से because I want you to get 180 and out of 180 and that student who get offended by the anger, the student who get offended by the scolding of the teacher, they don't get 180. Okay. Clear, Arhan? So that's the thing. Now we all know already know that delta H is equal to delta U plus NR delta T. Okay. Now what happens is for isothermal process delta U is 0 and delta T is 0. So delta H also becomes equal to 0. For an isothermal physical process taking place in a closed system having an ideal gas as a working substance, the enthalpy change and internal energy change both are 0. Is it clear? There is no isothermal process in actual Arman. What would you say about melting of ice? What would you say about melting of ice? Is it not isothermal? What would you say about boiling of water? Is it not isothermal? You are confusing between reversible and isothermal. Isothermal means temperature constant. I don't know, Arman, where you got your answers. There are so many isothermal processes actually happening. अरमान क्या समझ में नहीं आया बेटा कहां पे गुस्सा हो गया मैं I gave you the answer, isn't it? देखो बेटा many a times you ask a silly question तो आंसर के साथ डांट फ्री मिलेगी ठीक है ना Answer is going to be clearing your doubts and that will make sure that you never forget it again. Okay? Arhan, I hope you have got the answer, whatever you were asking. And everybody has got the answers, whichever one they were asking. So that's what we have as delta H equal to 0 for an isothermal physical process. Okay? Just remember one thing. Change of state is a chemical process. You can say state or phase, whichever way you call it. Okay, fine. Now we are going to talk about a little bit of calculations, a little bit of derivation, but that's not important. The final equation is important. So we know that dW is equal to minus PdV. Yeah. For T constant, PV are variable, but they are dependent. Now PV is equal to nRT, so P is equal to nRT by V. Clear? So what we are going to do is we are going to replace P by nRT by V. So we get dW is equal to minus nRT by V dV. Fine? P is equal to nRT by V dV. Now we integrate it. Integral 0 to W dW is equal to integral minus nRT by V dV V1 to V2. Now here nRT is a constant. So it can be taken out of the equation. So we get W is equal to minus nRT V1 to V2 dV by V. Now, integral 1 by x dx is equal to ln x, the natural log of x. Now, you don't need to go into very much detail of that. That's enough. So here we get the answer as W is equal to minus nRT ln V2 minus ln V1. Okay. When we have subtraction in log, it becomes division. Subtraction in log becomes division. So W is equal to minus nRT ln natural log V2 by V1. Yeah. Now when we write it further, W becomes equal to ln x is equal to 2.303 log x. So W becomes equal to minus 2.303 nRT log V2 by V1. So this is the work done for an isothermal physical reversible process. Copied it down? Clear? Okay, now one thing more. Here we are talking about reversible process. There NCRT it's given isothermal irreversible process also. Now we have isothermal irreversible irreversible process against constant pressure. Please remember, when we had reversible process, the pressure was not constant. If you want to keep the pressure constant, then in that case, it's going to become an irreversible process. Now there, W irreversible is equal to simply minus P delta V. Now P is the external pressure or the pressure against which the work is being done. Pressure against which the work is done. You may even consider it to be the final pressure, because ultimately this is going to become the pressure once the process is completed. Fine. So that is what we have as an isothermal process. Now we get along with something called a very nice thing, and that is what we know as the adiabatic process. Adiabatic process. Clear? Now please remember, you can just refer to this class to any of your friends. I hope everybody is understanding everything. Arhan, Radhika, Ananya, Prerna, everything clear? Okay, let's talk about the adiabatic process. Now, what is adiabatic process? Adiabatic process is the one in which Q is equal to 0. Heat supplied to the system is okay. Please remember, I didn't say temperature constant. I said heat 0. Okay. Okay. Yeah, it is thermally insulated. Now let's do a bit of thing. We know delta U is equal to Q plus W. It is adiabatic, it is adiabatic, it is adiabatic. QA is equal to 0. So delta UA is equal to W. So in case of adiabatic process, the internal energy change is equal to the work done on the system. Is it clear? The internal energy change is equal to the work done on the system. And that is what we know as the adiabatic process. Clear? Okay, let's have an example of an adiabatic process. Okay, when the expansion work, it's work done by the system, then it's negative. So you can say expansion would decrease delta U. Internal energy would decrease. So temperature would decrease. Okay, and compression would increase delta U. Compression would increase delta U. And that simply means temperature would increase. So compression is going to increase, cause the heating of the substance, of the gas, of the system, whereas expansion is going to cause the cooling of the system. So that is what we have as compression and expansion, and that is what we have as an adiabatic process. What we can do is we can do a slight experiment, a very simple slight experiment. And that is right now you can do it. And you can actually be a part of this experiment. Okay. So let's do this experiment. Take your palm. Okay. And now, once you have palm in front of your mouth, just do this way. I'll just show it to you. Just do it. Understood? Just do it. Tell me, you feel the air is hot or cold? Do it and tell me. Okay, it's hot. Now do one thing more. Take this palm and do it like this. Take it a little gap, not much, and do it. Blow it. Hot or cold? Priyanshu, hot, hot, hot. Yes, hot, 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 hot. Everybody hot. Now tell me, what is it? Hot or cold? Can anybody give me the reason why? And one more experiment. Again, do it. And now put your mouth very near to it and do it. Hot or cold? Can you give me the reason? Well, I have not given you the answers. You have given me the answers. It is hot, cold, hot. Reason. The answer is very simple. When you do it like this, it is just your body heat, and your body is hotter than the surrounding. And that is why the temperature on your palms are colder. They have the temperature of the surrounding. So palms, they feel it to be hot. But when you do this, the air coming from your mouth expands. It does not get the time to get the energy from the surrounding. It becomes an adiabatic expansion. The adiabatic expansion causes the cooling of air. Refrigerator, all these devices, they work on the principle of adiabatic expansion. Is it clear? Perfect. And when you're doing this, you actually don't give it a place to expand. So it is not just the velocity which matters, it also the space to expand which matters. Got it? So that is what we have as an adiabatic expansion. So I believe it's that time. Okay, let's talk about one more thing, and then it will be the time to see through the NCERT. We talk about something called the heat capacity. The heat capacity. Arhan, I couldn't understand the statement separate fan base, for example. I have got 7 students. That is my fan base. 7 student in total. So here we talk about something called the heat capacity. What is the meaning of heat capacity? Heat capacity is heat to be supplied to the system. Heat to be supplied to the system to increase the temperature by 1 degree Celsius or 1 Kelvin. 1 Kelvin or a unit. You may have it in Fahrenheit as well, but we are going to talk about that change in temperature in Kelvin or degree Celsius. Please remember, change, whether it be in degree Celsius or in Kelvin, is the same. So it does not making a difference. Clear? Now, please remember, heat capacity changes with the condition. With condition. Clear? Now, heat capacity is represented by capital C. That is equal to heat supplied to the system divided by the change in temperature. I'm not talking about differential. Since we are not doing physics as such, we are doing chemistry. So we are just going to go with the results. Okay. There is only 5 students here now. So Q is divided by delta T. Clear? So C is equal to Q by delta T. And please remember, you have to take care of the data that you use. So data is very important. So let's talk about the heat capacity in the various process. The very first process that we talk about is the adiabatic process. So heat capacity in an adiabatic process is going to be Q adiabatic divided by change in temperature. Can anybody guess what's the value? Q is 0 by delta T. That is going to be. So in an adiabatic process, the heat capacity is 0 because we are not supplying any heat. We are increasing the temperature or decreasing the temperature through work. Now let's go on with the second one. As you can very well see, we are so dependent on formulae that we are just talking about the formula. We are not applying our brains. How can heat capacity be 0? Temperature is changing. Yes, heat capacity is 0 because we are not providing any heat. Okay. Second one is isothermal. Isothermal is C at a constant temperature. That's going to be equal to heat provided at a constant temperature divided by delta T. So what's the value? And then is it clear why it is 0? What would be the value? At this time, it is going to be Qt something divided by 0. You need to remember if ice and water are in equilibrium and we provide heat to it, the ice keeps on melting. The temperature does not change till the time we have ice in the system. If we have boiling water, the water can keep on boiling, but the temperature is not going to change till that time water is there. Is that clear? So in an isothermal process, the heat capacity becomes infinity. Now let's get along with something called isochoric. Isochoric C at a constant volume would be equal to Q at a constant volume by delta T, and Q at a constant volume is delta U, the internal energy change. Is it clear? Now we have something called isobaric. We have C at a constant pressure. That will be equal to Q at a constant pressure divided by delta T, and that's equal to delta H by delta T. Now we know that delta H is equal to delta U plus P delta V, or you can say it is equal to delta U plus NR delta T. Remember? Remember? Okay. If you remember it, then in that case we have it is equal to delta U upon delta T plus NR delta T upon delta T, and that becomes equal to delta nahi, that becomes equal to CV plus NR. So Cp is equal to Cv plus Nr. That is for N moles. Now, if we have only one mole, that is, we divide the equation by N, it becomes Cp for 1 mole is equal to Cv for 1 mole plus R. Okay. So it would mean Cp for 1 mole minus Cv for 1 mole is equal to the gas constant R. I think now we can have a look at the NCRT. What we are left over with is chemical thermodynamics, which we are going to do in the next class. And we are going to finish off with chemical thermodynamics. Thermodynamics is a long chapter, big chapter. I hope it is interesting. Just read through it. I hope you will be able to understand it thoroughly without any confusion. Read it. Here is anybody who has a doubt about what the reversible and irreversible process are. Anyone has to ask anything here? Now I believe you will be able to understand this chapter the way NCRT has written it. Otherwise, the way NCRT has written it, even I get confused. Have you seen problem 5.1? Where is problem 5.1? Read through the problem 5.1? बेटा सारे ही नीट के क्वेश्चन है इसमें कौन सी बात है Today at 8 p.m. Tell all your friends to be there in the session at 8 p.m. We are going to talk about the strategy to get 180 out of 180 in NEET, and we will be discussing what exactly I am doing. Okay? So anybody who has a question whether my process is going to work or not, they are most welcome at 8 p.m. today. So read through this question. There are 4 questions here. Any kind of doubts? Enthalpy. After doing everything, they are talking about enthalpy. Read through it and you will be able to understand it. बेटा जब क्लास चल रही थी तब मजा नहीं आता मजा क्लास के बाद आता है क्लास जब चल रही थी तब तो बहुत इरिटेटिंग थी ना ये क्यों बता रहे हो ऐसा क्यों बता रहे हो वैसे क्यों नहीं बताया पहले ये क्यों नहीं बताया अब ये कहां चला गया डिटेल कहां है किसकी पूंछ कहां है मुश्किल होती है ना ओके नाउ रीड थ्रू इट एनीथिंग यार एनीथिंग यू नाउ दिस पार्ट इज नॉट फॉर यू एट द मोमेंट दिस पार्ट इज नॉट फॉर यू एट दिस मोमेंट डोंट डू इट वी विल डू इट लेटर Done? Look, extensive and intensive property, you can just read through it. Yeah, such a kind of a sequence in it. I am not able to understand it. Maybe they have some logic with that. We have talked about the heat capacity. We have talked about intensive, extensive property. We have talked about delta U measurement and Cp and Cv for ideal gas. That's what we have done. So in next class, we are going to start from here. Here. So you have to read till here. So that's what we have already done. Now we have an offer going on. Let's say talk about a little bit of commercial things, advertisements. You can use the code AVLive to get all 25% off on all Plus and Store subscription. Use the code AVLive, 25% off you are going to get. And it's a limited time offer. Here you have 15% iconic slash 15% plus extra 25% off. And get NEET UG Assure. There's some other program. Use the code AVLive if you want to get anything. It is 15 plus 25. So much discount with the code AVLive. हाँ 8 बजे क्लास है बेटा प्रेरणा. We are going to talk about the strategy for getting 180 out of 180. Clear? 2 p.m. you have Botany with Swati Batra ma'am. You have 3 p.m. Zoology with Sachin Kapur sir. You have 4 p.m. Chemistry with me. And you can join our Telegram channel for YouTube classes PDFs, t.me/NEET Elixir. And here you can get along with the subscriptions. Join with us on Unacademy app. Clear? And if anybody feels that this session is a little bit confusing, see that session maybe at 1.5x or 2x. You can actually see this session once again. Join with me on unacademy.com/Anoop Vashishtha. Follow me on this particular channel so that you get all the information about the plus and the special classes. Subscribe to NEET Elixir by Unacademy for the best live classes. And thank you. We are going to meet at 8 p.m. Remember, 8 p.m. We are meeting. Bye-bye. Take care. 8 p.m.